Hello class, today we are going to start chapter 3, which focuses on linear functions. At the end of chapter 1, we talked about what a function is. There's one output for every input that we have. When we're talking about linear functions, we're specifically concerned about functions that have variables with exponents of 1. Today's lesson is going to focus on graphing these linear equations and how we go about doing that. First thing we need to know is a linear equation is an equation that forms a line when graphed. So that's one way that we can pick it out to know that it's linear, is that it forms a line. Down below here you see ax plus by is equal to c. This is what we call the standard form of a linear equation. There are two other forms, slope-intercept and point-slope, that we will get to later in the chapter. This example below, 7x plus 2y is equal to -5, is a numerical example of what that would look like. There are 4 rules that we have about standard form. First rule, the a value is always positive. If it is not positive, we have to manipulate the equation so that it is positive. The second rule is that A and B can't both equal 0. So you can't have 0x plus 0y is equal to 7. You have to have a number in front of x, or a number in front of y, or in front of both. But it has to be in front of at least one of them, a number that is not 0. Next rule, A, B, and C are integers. So this means no fractions, no decimals whatsoever in the standard form of the equation. And the last rule is A, B, and C can't be divided by the same number. So if you're looking up at that example up top, 7, 2, and -5 cannot be divided by the same number. If it, for example, says 7, 14, and 21, you could divide all of those by 7, so you would have to. So those 3 numbers have to be what we call relatively prime. Other key piece of information for linear equations is knowing the x and the y intercept. The x-intercept is the x-coordinate where the line crosses the x-axis. So if you're looking at a graph and you have your line going through, we're looking at the x-axis, and you would pick out the x-coordinate from that point as your x-intercept. Likewise, on the y, we're looking where it crosses the y-axis. So again, we have our line going through, and we are looking for the y-coordinate where it hits the y-axis. So those are going to be helpful to us while graphing. First thing we need to do is decide if the equations are linear, and if they are, we're going to put them in standard form. So looking at this one on the left, first thing we've got to do is check if a is positive. We don't actually have an a value in this equation because we don't have any x's. So we could add in 0x if we wanted to, just to hold that place. Second thing we have to check is a and b are not both 0. We're okay there because we have a number in front of y, or we have a b value, so that is okay. Next thing we need to check is that a, b, and c are integers, so no fractions. What we have to check is if there is a way we can get rid of this fraction. So the opposite of dividing by 3, which is what the same thing as 1/3 is, would be multiplying by 3. So we're going to try multiplying the whole equation by 3. We still have no x's. Now 1/3 times 3 gives me just 1y, or just plain y. And -1 times 3 gives me negative 3. So what my equation is actually saying right now is y is equal to negative 3. So I don't have to worry about a. B exists, so we're okay there. I now have no fractions, and a, b, and c can't be divided by the same number. 1 and negative 3 can't be divided by the same number. So this is a linear equation, and there is its standard format. Second one, we have y is equal to 2x plus 9. First of all, you might notice that the y and the x are on different sides of the equal sign. In order to put it in standard form, we need them to be on the same side. Since we want our a value, or the number in front of x, to stay positive, I'm going to leave that 9x alone and move the y to the other side. Since I took the y away, there's nothing left on the left side, so we use 0 as that placeholder. Also, in standard form, that number value for c can't be on the same side as x and y, so we're going to go ahead and move that to the opposite side now. So I end up with negative 2 is equal to 9x plus y. Then we go through and check our requirements. A is positive. The number in front of x is 9. That's positive. A and b are not both 0. We have an a and a b, so we're good there. Checking to see if a, b, and c are decimals or fractions. There's none of those. And then negative 2, 9, and 1 cannot be divided by the same number. So again, this is linear. So what should indicate to you that something is not linear? We are looking to see if there is an exponent on any of the variables. If you notice in all of these equations, there was no exponent on the variable, which means it has an exponent of 1. If you see an exponent of 2 or negative 7 or anything other than 1, that is going to indicate to you that it is not a linear function. Go ahead, try these two on your own, determine if they are linear, and if they are, put them in standard form. The first one is indeed linear. Adding the 7x to the other side gets it into the standard form. The second one is nonlinear because we have the exponent of 2. If you have questions about what it means to be a linear equation or write in standard form, let me know when you get to class. Next thing we have to cover is how to find the intercepts of an equation. So we have 3x plus 4y is equal to 24. If you recall from a couple slides ago, to find our x-intercept, we are looking for a point that has an x value, comma 0. So what that means we can do is we can plug that 0 in the place of y in the equation. So I'm going to have 3x plus 4 times 0 gives me 0 is equal to 24. Adding 0 to anything doesn't really change it, so I have 3x is equal to 24, meaning that my x-intercept is 8. In order to properly write this out, you need to write it as an ordered pair. So the answer for the x-intercept is 0, 8. On the other side, if you're looking for the y-intercept, that was 0, y. So you're going to plug that 0 value in for the x this time. 3 times 0 still gives me 0. Adding 4y is equal to 24. Again, the 0 does not really matter, so we can just cross that out. Dividing by 4 on both sides give me an answer of y is equal to 6. So our final answer for the y-intercept is 0, 6. We can use these 2 points to graph the line. All you need in order to graph the line is 2 points, and we have 2 ordered pairs. So we figured out already that our x-intercept is 8, 0, and our y is 0, 6. In order to graph this, you simply put those on the graph. So I go over 8 and up 0, and for the y-intercept, over 0 and up 6. Then all you need to do is use some sort of straight edge. I conveniently get to use the line function that they give me on the computer but you want to make sure that you have a straight line going through both of those points. It should extend all the way through the entirety of the graph, so I don't want to see a line that just looks like this and connects the 2 points. I want you to make sure that it's going all the way from end to end on the graph. And the other thing that you need to do with your line is you need to make sure that you have arrows on the end to indicate that it's a line and it keeps going on forever and ever, even though we can only see this part on our graph. Go ahead, try this on your own, find the x and y intercepts, and then put it on a graph. X-intercept is -2, 0. Y-intercept is 0, 4. When you put that on the graph, it should look like the following. If you have questions about this type of problem, please let me know when you get to class. The other method of graphing that we have to talk about today is using a table. So this is similar to some things that we did in pre-algebra, kind of prepping for the idea of algebra. So this is an XY table. We put in our X values and we get out our Y values. Couple rules I have for class about what you can pick for the X values. You need to pick at least 2 negative values. The easiest 2 are -2 and 1. You have to include x is equal to 0. So no matter what you pick for x, everyone's table will have x is equal to 0. And then you have to pick 2 positives. Again, the easy ones are 1 and 2. Then you simply go through and plug those values into the equation. So the first one I plug in is -2. Negative times -2 is a +2. -5 gives me -3. -1 times negative is 1. -5 gives me 4. 0 times a negative is 0. -5 gives me -5. 1 times a negative is -1. -5 is -6. 2 times a negative is -2. -5 is 7. So we have 5 points that we can now put onto the graph. We treat each of them like an ordered pair. So I go -2 and down 3, -1, down 4, 0, -5, 1, -6, 2, -7. If you get a point that does not fall directly on your line, that means that you have done something wrong and you need to go back and check that you plugged in your values correctly, because this should be forming a straight line. Once again, drawing it all the way through the end of the graph and putting the arrows on both ends to indicate it's a line and it continues on forever. If you have questions about this or anything else from throughout the lesson, please let me know when you get to class.